Hi, I'm Aishwarya Dawa, a sophomore. In my study, I investigated how dust in our homes impacts obesity. I became interested in an article by a researcher from Duke University, Dr. Christopher Cassotis, who in 2019 found that households with higher childhood obesity had significantly more dust. This intrigued me as I have many family members and even childhood friends who have suffered from obesity and its comorbidities. Studies have found that children ingest as much as 100 milligrams of dust each day, mostly through breathing or consuming food with contaminated hands. Because dust is something very common in our households, it surprised me to read about the association between dust and obesity. In fact, other research studies have found over 390 chemicals in household dust, some of which are known hormone disrupting chemicals that are commonly found in daily products like plastic food packaging. As there is no clear evidence as to which of these chemicals are actually contributing to obesity, I wanted to investigate this further. As I read more, it caught my attention that the studies looked at dust samples only from the living rooms of houses. But it stands to reason that different parts of a household will have different types of chemicals. For example, more cleaning products are probably used in a bathroom compared to a living room. Therefore, the problem that I investigated was, does exposure to dust from different locations within a house lead to increased weight gain in some caterpillars? And I chose hornworm caterpillars because they gain weight quickly over a short period of time. So I hypothesized that caterpillars who were exposed to dust samples from specific locations in the household would have increased weight gain compared to controls, while other locations would not. If dust from specific locations did lead to increased weight gain, that potentially would help unearth the possible chemicals involved in driving obesity. So for the materials that I used, I first used hornworm eggs, which are laid by sphinx moths, and here is a picture of what the hornworm eggs looked like. Other materials that I used was food for the hornworm caterpillars, housing containers with breathable lids, a precision portable scale that was used in weighing the caterpillars, and a ruler to measure the lengths. I also used glass jars for collecting dust samples from each of the locations, and I used a lab spatula, camera, and data collection sheet as well. So for my procedure, I first collected dust samples over time from a bathroom, kitchen, garage, backyard, and an orchard. And each of these locations served as an experimental group in the study. And you can see in the bottom right corner is a picture of me collecting dust samples from the kitchen. So I also labeled 10 housing containers per group and transferred a newly hatched caterpillar into each container along with their food. And that can be seen in this picture right here, where a newborn caterpillar is being transferred into its housing container with a lab spatula. I then sprinkled approximately 250 milligrams of dust from each location to the corresponding housing containers, and that can be seen on the photo to the left, where you can see dust is sprinkled upon the caterpillar food and also in the surrounding container. The control group was not exposed to any dust. I chose to expose the caterpillars in the experimental groups to 250 milligrams of dust because it was at least 2 times what a child is typically exposed to daily. I then began recording the length and weight of the caterpillars every 4 days until the caterpillars either died or reached the chrysalis stage, which is where they developed into a cocoon. So this picture right here shows when I was weighing an 8-day-old caterpillar using the precision scale. And then this picture shows the weighing of a 16-day-old caterpillar. And then here is shown the measuring of the length of a 16-day-old caterpillar. And this last picture down here shows my overall experimental setup. So you can see how there were 10 housing containers for each of my 7 groups. So that brings me to my results. The caterpillars had their maximum weight at day of life 16 and reached the cocoon stage by day of life 20. So this graph right here shows the average of the maximum weights in milligrams for each group. The caterpillars from the control group had a average maximum weight of 7,600 milligrams on day of life 16. As you can see, the backyard, bathroom, and garage groups gained more weight in comparison to the control group. However, after running statistics on my data, I found that only the bathroom group reached statistical significance, with a p-value of less than 0.05, whereas the garage group approached statistical significance. So this graph over here shows the average lengths of the caterpillars in each group over a period of 20 days. So as you can see, the curves for all of the experimental groups are similar to the control group, with no major outliers. So my hypothesis was supported as caterpillars exposed to dust from both the garage and bathroom gained substantial weight, whereas other dust locations did not show increased weight gain. Furthermore, the average lengths of the caterpillars were similar for all groups, whereas the weights were not. This indicates that caterpillars in groups with higher weights were heavier than expected for having a normal length, which suggests the development of a level of obesity in the bathroom caterpillar groups. Therefore, my study found that bathrooms are the best place to start evaluating the specific chemicals that are contributing to obesity. And these chemicals might include air fresheners, cleaning sprays, and disinfectant powders. Who knows? But a future study undertaking laboratory analysis of dust samples from bathrooms would likely help to elucidate the precise chemical profile in the dust, thereby linking specific bathroom products to promoting obesity. And this is very important because currently approximately 700 million people worldwide are considered obese. Alarmingly, this number is projected to reach 1 billion by the year 2025. Due to the considerable comorbidities associated with obesity, such as diabetes, cancers, and hypertension, obesity has the potential to cripple our healthcare system. Therefore, it is crucial that any factors contributing to obesity are identified and mitigated where possible. And the key to achieving this may lie in bathroom dust.